How is pizza made? The pizza production line is an automated system widely used in the food industry to produce pizza on a large scale. This process is designed to optimize efficiency, enhance productivity, ensure consistent quality, and reduce labor costs. Below is the process for producing frozen pizza through an automated production line. Dough preparation. The process begins with dough preparation, the fundamental ingredient of pizza. Wheat flour is carefully selected to achieve the ideal fineness and adhesion. Ingredients such as water, yeast, sugar, salt, and olive oil are precisely measured and mixed in large industrial mixers. These mixers can knead the dough to the desired smoothness and elasticity, creating dough with good rise when baked. The dough is then allowed to rest so that the yeast can activate, helping to increase the dough's volume and softness. Dough dividing and rounding. Once the dough reaches the required elasticity, it is transferred to a dough divider. This machine divides the dough into equal portions, ensuring uniform pizza bases. After dividing, these dough portions are moved to a dough rounding machine, where they are shaped into balls or flat discs. This process ensures each pizza base has precise size and shape. Dough pressing and shaping. The dough balls are then placed into a dough press, where they are flattened into bases with consistent thickness and shape. The dough press can be adjusted to produce different types of pizza bases, from thin crust, deep dish, to stuffed crust. The bases are pressed into precise shapes, creating an ideal surface for spreading sauce and adding toppings later. Sauce application. After the bases are pressed, they are moved to the sauce applicator. The automatic sauce applicator spreads a layer of tomato sauce or other sauces over the surface of the pizza base. The amount of sauce is carefully controlled to ensure each pizza has consistent flavor and even sauce distribution. Topping application. Next, the pizza bases pass through the topping applicator. This machine can apply various toppings like cheese, meat, vegetables, and spices onto the base. The process can be fully or semi-automated, ensuring even distribution of toppings and avoiding ingredient waste. The topping applicators can be programmed to add various toppings according to production requirements. Baking. After toppings are applied, the pizzas are transferred to the oven. Industrial ovens, often conveyor belt types, maintain consistent temperature and humidity, ensuring even baking on both the top and bottom of the pizza. The conveyor belt moves pizzas through different temperature zones, achieving the desired crispness of the crust and the melting of the cheese. Baking time typically ranges from 8 to 12 minutes, depending on the size and type of pizza. Automated temperature and time controls ensure the pizzas are not burnt or undercooked. Cooling and packaging. Once baked, the pizzas are quickly cooled using a rapid cooling system, preventing bacterial growth and maintaining quality post-baking. Rapid cooling helps retain the crust's crispness and the topping's freshness. The pizzas are then packaged in specialized packaging, typically sealed plastic bags or cardboard boxes with protective inner layers. The packaging is designed to keep the pizzas intact and prevent deformation during transportation and storage. Freezing. Packaged pizzas are moved into freezing chambers using blast freezers or storage freezers with very low temperatures. The freezing process extends the shelf life of the pizzas, preventing bacterial growth and preserving the flavor and structure of the pizza until it reaches the consumer. Quality control. After freezing, pizzas undergo quality checks before being shipped. Each batch is randomly sampled to ensure it meets standards for flavor, texture, and freshness. These standards include checking the crust's crispness, cheese melt, and even distribution of toppings. Microbial testing is also performed to ensure the product is free from harmful bacteria. Distribution. After quality checks, the pizzas are transported to distribution centers or retail stores, ensuring the cold chain is maintained during transit to preserve quality. Frozen pizzas offer numerous benefits, being easy to store and use, reducing food waste, providing high convenience, and offering a variety of flavors. Frozen pizzas can be stored for an extended period without losing their original taste and quality. This allows consumers to keep the product in their home freezer and use it whenever needed. With their long shelf life, frozen pizzas help reduce food waste due to spoilage. Consumers can purchase and store multiple pizzas for various occasions without worrying about the product going bad. Frozen pizzas offer high convenience, especially in emergency situations or when consumers lack cooking time. Simply reheating in the oven or microwave, the pizza is ready to enjoy. Frozen pizzas are produced with a variety of flavors and toppings, catering to the preferences and needs of diverse customer groups. Consumers can easily choose from traditional pizzas like pepperoni and seafood to more unique flavor combinations. The frozen pizza manufacturing industry is continuously evolving and improving to meet the increasing market demand. Freezing technology is being enhanced to boost efficiency and shorten freezing times. New technologies can help pizzas reach freezing temperatures faster without affecting their structure and taste. To cater to health-conscious consumers, manufacturers are developing pizzas with healthier ingredients, such as whole wheat flour, organic tomato sauce, and low-fat toppings. Frozen pizza packaging is also being improved to be more environmentally friendly. Recyclable and biodegradable packaging materials are being researched and developed to minimize environmental impact. Manufacturers are also exploring new and unique flavors to attract consumers. These innovations may include pizza varieties that combine different culinary traditions or unique toppings and sauces not previously available on the market. The frozen pizza production line using an industrial process is a complex yet efficient operation, combining modern technology with traditional processing techniques. From ingredient preparation, dough dividing, pressing bases, sauce application, topping, baking, to packaging, each step is meticulously performed to ensure the highest quality. Frozen pizzas offer convenience, diverse flavors, and long-term storage capability, meeting the growing demand of consumers. The challenges and future trends in this industry will continue to drive innovation and improvement, ensuring that frozen pizzas not only retain their traditional taste, but also become richer and more appealing to global consumers. How hamburgers are made. The process of creating a McDonald's hamburger is a well-coordinated system involving several meticulously planned steps that ensure each burger maintains the brand's standard of quality and flavor. This journey begins with beef preparation and extends through packaging, transportation, cooking, and assembly at the restaurant. Each phase plays a crucial role in delivering the final product to the customer efficiently and consistently. This comprehensive process highlights McDonald's commitment to quality and efficiency in fast food production. The journey of a McDonald's hamburger starts at the beef processing stage. To ensure high-quality hamburgers, McDonald's sources beef from approved suppliers who adhere to stringent standards. Upon arrival at the processing facility, the beef is carefully cut into small, uniform pieces. This initial step is crucial because uniformity in beef pieces ensures that the hamburger meat maintains a consistent quality and texture, which significantly impacts the taste and overall quality of the hamburgers. Consistent texture and flavor are essential characteristics that define McDonald's hamburgers, making this step foundational to the entire process. After the beef is processed into uniform pieces, it is transported to a McDonald's supplier where it undergoes grinding. Grinding transforms the beef into hamburger meat with a fine consistency, which is essential for creating the patties. During the grinding process, the meat is mixed with essential ingredients, such as salt and seasonings. The purpose of this blending is to achieve a uniform flavor throughout the hamburger meat. Precision in this mixing stage is crucial because it ensures that every patty, regardless of its position in the batch, will have the same taste and seasoning, contributing to the signature flavor of McDonald's hamburgers. Once the beef mixture is well blended, it is formed into patties. The formation of patties involves shaping the ground beef mixture into consistent, uniform sizes that meet McDonald's specifications. These patties are then immediately frozen to preserve their freshness. Freezing is a key step that helps maintain the quality and safety of the hamburger patties by halting bacterial growth and preserving the meat's natural juices and flavors. This stage also ensures that the patties remain in prime condition during transportation and storage. The frozen patties are packaged in specialized containers designed to maintain the meat's freshness and safety during transportation. These containers are insulated to prevent heat transfer and maintain a consistent low temperature. The packaging is also sealed to prevent contamination, ensuring that the patties remain fresh until they reach their destination. Once packaged, the patties are transported to McDonald's restaurants across the country using various methods, including trucks, trains, and airplanes. Each transportation method is equipped to handle perishable goods efficiently, keeping the patties at the required temperature to ensure they arrive in optimal condition. Upon arrival at a McDonald's restaurant, the frozen patties are carefully unloaded and stored in a refrigerated area until they are ready to be cooked. Storage conditions at the restaurant are monitored to ensure that the patties remain at the appropriate temperature, preserving their quality and safety. When it's time to prepare a hamburger, the patties are thawed and cooked on a griddle at a precise temperature for about 90 seconds on each side. This controlled cooking process ensures that the patties are cooked evenly, enhancing their flavor and texture. The McDonald's kitchen is designed to maximize efficiency and effectiveness in producing a large volume of food quickly and consistently. The kitchen layout typically includes separate areas for food preparation, cooking, and assembly, each equipped with the necessary tools and equipment for specific tasks. The food preparation area is where ingredients such as vegetables are prepared for cooking. This area involves tasks such as slicing vegetables, seasoning and marinating meat, and mixing sauces and condiments. Proper preparation ensures that all ingredients are ready and available for cooking, contributing to the efficiency of the kitchen operations. The cooking area is where the UAL food preparation takes place using equipment such as grills, fryers, and ovens. This area is equipped with heat controls and ventilation systems to manage excess heat and smoke. Specialized equipment, such as machines for making French fries, is also present in this area. Workers use spatulas and other tools to cook the burgers, ensuring they are cooked evenly and thoroughly. The precise control over cooking conditions helps maintain the quality and consistency of the food. The assembly area is where the cooked food items are put together and prepared for serving. This area involves tasks such as assembling burgers and sandwiches, adding condiments and toppings, and packaging the food for delivery or takeout. Workers in the assembly area use tongs, spatulas, and other tools to handle the burgers and other ingredients. They also utilize digital order systems to track individual orders and ensure accuracy in preparation and serving. The drive-through system at McDonald's allows customers to place and receive their food orders without leaving their vehicles. Customers place their orders using a speaker system located at the drive-through entrance and pay for their orders using a payment kiosk. Once the order is placed, it is sent to the kitchen, where the food is prepared and assembled. The integration of the drive-through with the kitchen operations ensures that the prepared food is promptly assembled and ready for the customer by the time they reach the pickup window. This system contributes to the overall efficiency and convenience of McDonald's service. After assembly, the hamburgers are served to customers either through the drive-through or at the restaurant counter. McDonald's implements strict guidelines for food safety and sanitation to ensure that all food items meet their quality standards. The kitchen staff is trained to follow these guidelines rigorously, including regular checks for temperature, cleanliness, and proper handling of ingredients. McDonald's continually seeks to improve its processes and operations to maintain and enhance the quality of its hamburgers. This involves ongoing research and development in food preparation, packaging, and cooking techniques. By staying updated with the latest advancements in food technology and customer preferences, McDonald's ensures that it delivers a product that meets high standards of taste, quality, and safety. The journey of a McDonald's hamburger from beef preparation to the final product served to the customer involves a complex and well-coordinated process. Each stage, from cutting and grinding the beef to freezing, packaging, transportation, cooking, and assembly, plays a vital role in ensuring that the hamburgers maintain consistent quality and flavor. The efficient design of the kitchen and the integration of modern technology in order processing further enhance the ability to deliver a high-quality product quickly and reliably. This comprehensive approach reflects McDonald's commitment to excellence in fast food production, ensuring that every hamburger meets the expectations of their customers. The production of chocolate is a multifaceted process involving numerous chemical reactions. The key stages where these crucial reactions occur to develop the proper chocolate flavor include the fermentation, drying, and roasting of cocoa beans, as well as the grinding and mixing of chocolate ingredients. During fermentation, essential precursors for subsequent chemical reactions are formed. Roasting is particularly critical due to the Maillard reaction, which produces aromatic compounds. In this article, we will explore the significant chemical reactions involving proteins, carbohydrates, lipids, and polyphenols. Additionally, we will discuss other components that may naturally occur or form during the production process, such as methylxanthines, aldehydes, esters, ketones, pyrazines, acids, and alcohols. Chocolate is a product widely consumed across generations and is rich in fats, proteins, carbohydrates, polyphenols, and other bioactive compounds. Cocoa beans are the primary raw material for chocolate production. The process involves several steps: fermenting, drying, roasting, grinding the cocoa beans, mixing all ingredients, cocoa mass, sugar, cocoa butter, emulsifiers, flavorings, and milk components if needed, conching and tempering. The key chemical reactions occur during the fermentation, drying, and roasting of cocoa beans, and in the production of chocolate mass. These reactions are crucial for developing the desired flavor and aroma. Cocoa bean fermentation is a process where yeast and bacterial growth occurs within the pulp at cocoa plantations. This stage is critical for creating essential precursors necessary for subsequent chemical reactions during chocolate manufacturing. Fermentation comprises 3 stages. First stage, dominated by anaerobic yeast, lasting for 24 to 36 hours with low oxygen and pH levels. During this phase, the yeast converts sugars into alcohol and carbon dioxide. Second stage, dominated by lactic acid bacteria, which become active between 48 to 96 hours. These bacteria convert sugars into lactic acid, lowering the pH further and contributing to the flavor development. Third stage, dominated by acetic acid bacteria as aeration increases. In this stage, an exothermic reaction occurs, converting alcohol into acetic acid, raising the temperature to 50 degrees or higher. This heat helps kill the seed embryo, stopping germination and aiding in flavor development. These fermentation stages are crucial for creating the complex flavor precursors necessary for developing the proper chocolate aroma. Drying of cocoa beans. After fermentation, the drying of cocoa beans is carried out to reduce moisture content and complete the oxidation processes initiated during fermentation. Once dried, cocoa beans have a moisture content of 6 to 8%. Low moisture levels are essential to prevent mold growth and stabilize the beans for transportation and storage. The drying process can be done naturally in the sun or using mechanical dryers. Proper drying ensures that the beans do not develop off flavors and retain their quality during storage. Roasting of cocoa beans. Roasting is a pivotal stage in chocolate manufacturing and is typically the first step at the factory. This high-temperature process is essential for the Maillard reaction, which develops the characteristic aroma and flavor of chocolate. Roasting also reduces undesirable components, decontaminates the cocoa beans, and facilitates the removal of the bean shells. During roasting, complex chemical reactions occur, transforming the flavor precursors formed during fermentation into the rich flavors associated with chocolate. The duration and temperature of roasting can be adjusted to achieve different flavor profiles, with lighter roasts preserving more of the bean's original flavors and darker roasts producing more intense and robust flavors. Grinding and mixing. Grinding and mixing all chocolate ingredients are critical to achieving the proper particle size and smooth texture. The main ingredients used in chocolate production are cocoa liquor, obtained by grinding cocoa beans, cocoa butter, obtained by pressing cocoa liquor, sugar, and milk, in the case of milk chocolate. The grinding process reduces the particle size of the ingredients to about 20 microns, ensuring a smooth and creamy texture. Proper mixing ensures that all ingredients are evenly distributed, which is crucial for flavor consistency and texture. Conching is a mixing and heating process that further refines the texture and flavor of the chocolate. During conching, chocolate is continuously mixed and aerated, which helps evaporate volatile acids, achieve the proper viscosity, remove excess moisture, and develop the desired color. This process can last from a few hours to several days, depending on the desired quality of the chocolate. Conching improves the smoothness and mellowness of chocolate, reducing any gritty texture and enhancing the overall mouthfeel. Tempering is the final critical step before molding chocolate into bars or other shapes. This process involves heating and cooling the chocolate to specific temperatures to form stable cocoa butter crystals. Proper tempering ensures that the chocolate has a smooth, glossy finish and snaps cleanly when broken. It also ensures that the chocolate does not develop a white, powdery appearance known as bloom, which occurs when cocoa butter crystals separate from the cocoa solids. Molding and packaging. Once tempered, the chocolate is ready to be molded into bars, bonbons, or other shapes. The tempered chocolate is poured into molds and cooled to solidify. A final inspection ensures there are no air bubbles and the chocolate is intact. The chocolate is then wrapped in foil or paper to maintain freshness and protect it from external elements. Despite their small appearance, chocolate bars generate significant revenue annually, requiring a substantial amount of packaging materials for wrapping. These processes must be carefully controlled due to the impact of chemical reactions and their products on the flavor and aroma of chocolate. The main flavor compounds in chocolate are polyphenols, present in raw cocoa beans and undergoing various transformations during production, and pyrazines formed during production, followed by aldehydes, ketones, and esters. Some reaction mechanisms during cocoa bean and chocolate processing have been discovered and identified. However, as new analytical techniques emerge, new compounds are being identified, e.g., saloinositol, 1-kestose, and 6-kestose cocoa acids. Their relevance in reactions during cocoa bean and chocolate processing and their impact on overall chocolate characteristics, flavor, aroma, color, remain to be revealed. Furthermore, as analytical tools become more sensitive in detecting and quantifying identified compounds, new knowledge in this field is anticipated. This knowledge will not only contribute to science, but also benefit cocoa bean and chocolate manufacturers who can select varieties and processes to increase desirable compound content and reduce less desirable ones, as well as optimize the ratios of different compounds crucial for overall quality. The production of chocolate involves a series of complex and meticulously controlled processes, each contributing to the development of the distinctive flavors and textures we associate with high-quality chocolate. Understanding these processes and the chemical reactions involved not only enhances our appreciation of chocolate, but also drives innovation and improvements in chocolate manufacturing. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.